Number 6. The gravitational field strength on the moon is 1.6 newtons per kilogram. Okay? If a rock on the moon weighs 200 newtons, how much does that same rock weigh on Earth? All right, in class, we found our weight on the moon. This is a similar problem, only it's working backwards. We know our weight on the moon. We're trying to find out our weight on Earth. So rather than do the guess method, what we're going to do for this problem is separate it into two different sides. On one side, everything over here is going to have to deal with the moon. On the other, the Earth. All right, let's start with what we want to find. So the final question asks us, how much does the rock weigh on the moon? On the Earth. So what we have to end up with is this weight. I'm going to add an E to that, so I remind myself I'm looking for the weight on the Earth. That's our final answer. Okay, to get that, we want to use this equation. Weight is equal to mass times gravity. Well, we know what the acceleration of gravity is on the Earth. It's that 9.8 that you see all the time. The problem is we do not know the mass of this rock. Okay, so we have to use the information that we know about the rock on the moon in order to find its mass. So let's start there. In the problem, they told us the moon has a gravitational acceleration of 1.6. So on the moon, g of the moon, put that little m there to remind you, is equal to 1.6 meters per second squared, or newtons per kilogram. Okay, we also know that the weight of this rock on the moon is 200 newtons. So weight of the rock on the moon is 200. We need to find mass. So just like on problem 3 and problem 4, we have an equation for that. Mass is equal to weight divided by that acceleration of gravity. Well, our weight is 200 divided by acceleration of gravity is 1.6. So your mass of this rock is equal to, plug it in the calculator with me, 200 divided by 1.6 gives you 125. That is kilograms. Okay? So this rock has a mass of 125 kilograms. Okay. Now we're going to use that mass on this other side of our problem. Because if you remember, hopefully you got this earlier, hint, hint, your mass is the same no matter where you are. So my mass on Earth is the same as my mass on the moon, in outer space, on Jupiter, wherever. My mass stays the same. It's the amount of stuff that makes me up. Okay? So use that mass now over here on this problem. So the mass of the rock we just solved was 125 kilograms. Well, now we can use our equation. Weight is mass times gravity. Our mass is 125. The acceleration of gravity on Earth is 9.8. Multiply those two to get your answer. Make sure your answer, whatever it is labeled as a force, so our unit is newtons.